I misspoke in the last clip, saying that the numerator was in units of omega times units of position, which wouldn't be good anyway. I did have a problem with that. And let's come back and make sure we understand where these units come from. When we found the units of our unit tangent vector, when we found our unit tangent vector, we saw that the omega that we factored out of the square root here in the denominator divided the omega in the numerator, and naturally our unit tangent vector, being the derivative of a vector divided by the magnitude of that derivative, is going to have to be unitless. So that what we ended up with for the unit tangent vector is completely unitless. There are no meters, no seconds on any of these numbers. Now the omega itself is in units of radians per second, presumably, or in units of angle divided by units of time, whatever those units might be. When we take the derivative of the unit tangent vector, we do get the factor omega. Now let's look up here. We do get a factor of omega throughout the numerator. The denominator remains unitless. So the numerator is in units of omega, not units of position, and not units of omega times units of position. The denominator is unitless. So that t prime of t is in units of omega, and a typical unit, probably not for motion of a planet, but would be radians per second. That would be our SI unit of omega. So that t prime of t does come out in units of omega. And the main thing you should carry away from this is it's important to consider the meanings of your symbols, whether they have units, whether they're unitless, and whether your final result is consistent with the units of your initial function.